Hello everyone, welcome to my channel. In this video I will explain you Bresenham's line drawing algorithm. In the previous video we learned DDA line drawing algorithm. If you haven't watched it yet, I will provide the link in the description box. First of all, let's draw a computer screen in order to understand how computer draws a line on screen. As I explained in the previous video, computer screen consists of many pixels. In order to draw a line on computer screen, we should consider pixel and its computations. We can show each pixel as xy. We should give endpoints and computer will draw a line between these endpoints. But in order to do this, computer should calculate which pixels to choose. If slope is less than 1, then it should decide lower or upper pixels. If slope is more than 1, then it should decide left or right pixels. Now let's draw a line on screen. When slope is less than 1, then x-coordinate will change with unit interval. It means that at every iteration, the next coordinate of x will increase by 1. In this case, computer should calculate y-coordinate. The intercept point will be between yk and yk plus 1. Computer should decide yk or yk plus 1, which pixel is nearest to intercept point. Let's draw a parallel line to x-coordinate in intercept point and call it as y. Let's call the distance between y and yk as d1, the distance between yk plus 1 and y as d2. As you know, the general line equation is y equal mx plus c. Here m is slope, c is intercept point. If m is less than 1, it means that x will change with unit interval. So computer doesn't need to calculate the value of x because at every iteration it will increase by 1, as I said. If we put the value of xk plus 1 in general line equation, we can get this equation y equal mxk plus 1 plus c. This is one of our equations which we will use in our further calculations. Now let's calculate the value of d1. d1 equals, as you see in the graph, y minus yk. If we put the value of y from the previous equation, we can write that d1 equals mxk plus 1 plus c minus yk. d2 equal yk plus 1 minus y. Again, we put the value of y from the previous equation, then d2 equals yk plus 1 minus mxk plus 1 minus c. Now we should calculate the difference between d1 and d2, because the result will decide which pixel is near to intercept point. If d1 minus d2 is less than 0, it means that the distance between intercept point and yk is less than the distance between intercept point and yk plus 1. So in this case, computer will choose the lower pixel, yk. The next coordinate will be yk. If d1 minus d2 is more than or equal 0, then computer will choose upper pixel. And the next coordinate of y will be yk plus 1. Let's calculate d1 minus d2. We will replace the values of d1 and d2 based on previous equations. As a result, d1 minus d2 will be mxk plus 1 plus c minus yk minus yk minus 1 plus mxk plus 1 plus c. Now let's simplify this equation. d1 minus d2 equals 2mxk plus 1 minus 2yk plus 2c minus 1. Here m is slope, which equals delta y divided by delta x. We can replace the value of m by delta y divided by delta x. After replacing it, we need to multiply each side by delta x in order to avoid fraction, because it is very expensive computations for computer. So if we multiply each side by delta x, our equation will be delta x into d1 minus d2 equals delta x into 2 delta y divided by delta x into xk plus 1 minus 2yk plus 2c minus 1. Delta x into d1 minus d2 is our decision parameter. We can call our decision parameter as pk. So pk equals delta x d1 minus d2. The sign of pk will depend on the sign of d1 minus d2, because delta x will be positive. In this case, the difference between d1 and d2 will determine the sign of pk. Now let's calculate the value of pk. Let's calculate. After multiply operation, we will get pk equals 2 delta y xk plus 2 delta y minus 2 delta x yk plus delta x common 2c minus 1. Now let's find pk plus 1. We will just replace xk and yk with xk plus 1 and yk plus 1. After this operation, let's find difference between pk plus 1 and pk. So we will get 2 delta y xk plus 1 plus 2 delta y minus 2 delta x yk plus 1 plus delta x 2c minus 1 minus 2 delta y xk minus 2 delta y plus 2 delta x yk minus delta x 2c minus 1. Let's remove this and this one. So we will, after simplification, we will get 2 delta y xk plus 1 minus xk minus 2 delta x yk plus 1 minus yk. So pk plus 1 equals pk plus 2 delta y xk plus 1 minus xk minus 2 delta x yk plus 1 minus yk. So pk plus 1 is our decision parameter for next coordinate. We already know that when slope is less than 1, then xk plus 1 will be xk plus 1. The next coordinate of x will increase by 1. If we put the value of xk plus 1 in our general formula, we will get this new equation for pk plus 1. Our new decision parameter will be pk plus 2 delta y, because we will remove xk and minus xk, minus 2 delta x yk plus 1 minus yk. This is our new decision parameter for next coordinate when slope is less than 1. If slope is more than 1, we will just change x, y parameters. So it will be pk plus 2 delta x minus 2 delta y xk plus 1 minus xk. This is our decision parameter for next coordinate when slope is more than 1. Now let's find the initial decision parameter. So first of all, we should consider that in the initial point, the value of x and y will be xk and yk. Now let's write the formula of pk, which we got in our previous calculation. Just to remind you, I'm going to show you. P initial equals 2 delta y xk plus 2 delta y minus 2 delta xyk plus delta x2c minus 1. Here we can replace c with y minus mx. Now let's continue our calculation. For pk, we are going to get this equation. Here we will replace m with delta y divided by delta x, and pk equals 2 delta y xk plus 2 delta y minus 2 delta x yk plus delta x times 2y minus 2x delta y divided by delta x. Oh, sorry, minus 1 should be inside, yes, equals 2 delta y xk plus 2 delta y minus 2 delta x yk plus, if we multiply it, it will be 2 delta x y minus 2 delta y x minus delta x. So here we will simplify our equation. First of all, we should replace x and y with xk and yk. After replacing, we will simplify our equation, and for p initial we will get 2 delta y minus delta x. This is our initial decision parameter. So initial decision parameter will be 2 delta y minus delta x when slope is less than 1. If slope is more than 1, we will again change the xy parameters. So we will get p initial equals 2 delta x minus delta y when slope is more than 1. Now let's see our conditions. First of all, let's see what happens when slope is less than 1. We know that when slope is less than 1, the next coordinate of x will be xk plus 1. So computer should decide y coordinate in this case. If pk, decision parameter, is more than and equal 0, then the next coordinate of y will be yk plus 1. So in this case, yk plus 1 will be nearer to intercept point, and computer will choose yk plus 1 pixel. Next coordinate will be xk plus 1, yk plus 1. If pk is less than 0, then next coordinate of y will be yk. So computer will choose lower pixel because yk will be nearer to intercept point. And next coordinate will be xk plus 1, yk. When slope is more than 1, then y coordinate will change with unit interval. So next coordinate of y will be yk plus 1 at every iteration. So computer should decide for x coordinate in this case. Now let's see conditions. When slope is more than 1, if pk more than and equal 0, then the next coordinate of x will be xk plus 1. next coordinates will be xk plus 1, yk plus 1. If pk is less than 0, then next coordinate of x will be xk. Oh, sorry. Xk plus 1 will be xk, and next coordinate will be xk, yk plus 1. Okay guys, all those long mathematical operations were just for understanding the derivation of Bresenham's line drawing algorithm and to get the logic behind this algorithm. However, in exam, all you need is to memorize these equations, because I don't think that you will have enough time to calculate all those equations from the beginning. I believe that you will definitely pass the exam. Also, I will upload paper screens in the description box so you can download it easily. If you found this video helpful and want more videos like this, please let me know. Bye bye.